Let's rewrite this create greeting function to the arrow function style. So we'll say arrow greeting is message name, and then the fat arrow with some braces, and return message plus name. Now that actually looks about the same. The only difference really is that this is on the right side, whereas the function keyword is on the left side. So that'd be here, whereas this would go here. But we can actually make this much smaller. First, let's remove the braces. So we'll remove him, and move everything up to the same line, and remove the return keyword. So this will automatically return message plus name. You don't have to write the return keyword when you don't have the braces in there. Second, if there's only one parameter, like you only take in a message, you can actually get rid of the surrounding parens here and just say message would return message, or message would return hello, or whatever you want it to return. So that's why you'll see something like var squared is x, which returns x times x to be x squared. An extremely common scenario that you've probably run into before, whether through click handlers or anything else, is that you write a function to handle some sort of action, and you write the body of the function, and you'll run into the scenario where you'll assign that to this because you actually want to get the name off of the parent scope, and the name doesn't exist inside of this scope, so you have to do the that is this, and then to get this in here you refer to that, and it can get pretty confusing. Now the arrow function actually helps handle this scenario. I'm going to delete the function keyword, I'll use the arrow function syntax, and then that here can just become this. I can delete this line, delete that, and this now refers to the outer scope outside of this function because it's passing in this lexical scope that's coming in from above the function. This is no longer referring to the scope inside of the function, it's referring to the scope that's outside of the function. And again, if you'd prefer to do this in one line of code, we can delete this brace and bring everything up a line. We can delete the semicolon and delete the closing brace. We can remove the paren from here and handle this nicely in a simple one-liner. So when I run this, you can see it prints out, hello, John, because this is actually this handler right here, and it's getting this message through here, which is coming from here. So when the message goes here to here to here, down into our arrow function, I add it to this name, and this name is this name now. A long-standing gotcha with JavaScript is how var works. So if I have this message assigned to hi, and I have this message assigned to bye, you'd probably think, well, this one's inside of a block, so it should have no impact on what this message does up here. But if I run this, you'll actually see that that isn't the case. Bye is being logged out because this is the same message and it's being reassigned to bye. Now, ES5 does have function scoping, so if I were to create a function and lock it inside of there, then it wouldn't have any impact and I would get hi. But if I were to create a for loop or some other thing that could use a block, then that wouldn't work and I'd get the same result as logging out bye each time. To help with this problem, we now have let in ES6, which will allow me to use block scoping. So if I rerun this, you'll see that we still get hi, even though we have message here and message here. So this message, because it's inside of a block, even though it's not inside of a function, has no impact on the assignment of this message. They are two separate and different entities. Let's explore this behavior in a bit more detail by creating an array of functions and a loop where we say var I is assigned to 0, I is less than 10, and I is incremented, so I++. Then we will add a new function to our array each time we go through, which will store I and log it out for us. So if we loop through the array of functions using a for each, which will pass in f, and then invoke f, again, this function here, which is being passed in through our for each, is simply this function storing our I. You'd think that we'd get 0 through 9, but in fact, when we run this, we'll get tens because this I is that same I being used and reassigned each time. If I use let instead of var now and rerun this, you'll see that I get 0 through 9 and it stops before getting to 10 because this is creating a new I each time you go through the for loop. So what this really means in the end is that if you're used to bringing your variables up to the top of a scope using var and things like var I, var temp, where you want to be careful because you're afraid of hoisting behaviors due to this I and this temp, feel free now to use the let keyword, and instead of declaring it at the top, you can declare it inline inside of the for statement, as well as declaring it inside of the for block, and it'll safely create this temp each time it goes through the for block. Default arguments in ES6 allow you to assign some defaults to these guys. So if I run this right now, you'll see I'll get undefined, comma, undefined because nothing was passed in for greeting or name. So when they get logged out, they're both undefined. If I want his name to at least default to John, if I don't pass anything in, I can get undefined John. I didn't pass anything in here, but I said the name should at least be John, so it logs out the name as John. If I pass in hello here and then run this, you can see I get hello John. So hello comes through the greeting, logged out here is hello, and the name still defaults to John and then is logged out here. If I say hello, comma, Bill, the default will be overridden and I'll get Bill instead of John because the default was John, but I said explicitly to say Bill. Now where this gets a little bit crazier is when you assign a default function to one of the arguments. So right now complete is undefined, so it'll say undefined is not a function when I try to invoke it. But if I pass in a function and say log complete and I run this, you can see it logs complete out because it invokes it when it's passed in. But I can actually take this function, I'll cut it out of here and then assign that as the default function, and then I'll rerun it and you'll see I still get complete. Now we can actually make this a little bit shorter using the arrow syntax that I've covered before. So if I do that and then get rid of the braces and then bring everything up to the same line, you can see that I can assign a default function all within that same line, run it again, and I still get complete. And if you want to go completely crazy with arrow functions, which I don't recommend, you could go let receive and we'll assign it to an arrow function, delete these braces, pull everything up to the same line, and then just invoke it this way, and it still runs. And this just doesn't look like JavaScript. It's not JavaScript you'd write, but it's very unfamiliar with the new syntax with the arrow functions and the default assignments all working on the same line.
As a developer coding in JavaScript with ES5, if you want to declare a variable whose value is to remain constant, it's a best practice to name that variable in all uppercase letters. This doesn't actually prevent the variable from being reassigned to a different value, but is more like a note to other developers saying, hey, this is my intention. Notice how if I console log out value, what is returned to us is foobar because that's the last assignment that was given to that variable. Ecmascript 2015 introduces us to const declarations. A const declaration allows us to declare a variable that is read-only. In the example, if I try to reassign the value to foobar, we will see the value is read-only error thrown because we have declared this variable as a constant. It's important to understand that what a const is not actually a constant variable, but a constant reference. In the example, I have declared value to be an object. Down below, I can assign and reassign properties of that object without breaking my const rules. If I console log out value, we'll see an object with a key value pair of foo and bar returned to us. However, if I try to reassign the value of foo to just the string literal bar, our value as read-only error is once again thrown, because I have changed the reference of this const declaration. There are many common use cases for why you might want to use a const in your application. Perhaps you're using a third-party API where you want to specify an API key, an API secret that will remain constant throughout the use of your application. Some other common use cases include assigning a port number in a Node application, perhaps creating a margin that is used for profit and loss calculations within an application, or maybe you just want a constant reference to pi which you know will not change. Another important thing to note is that like let declaration, const declarations adhere to block scope. Block scope can simply be understood as anything between two curly brackets. In the example, if true, open curly brackets, const foo equals bar, and then outside of those curly brackets, I try to console log foo, we will see that error foo is not defined. This is because the console log is outside of the block scope of the const declaration. However, if we move the console log within that block scope, we'll see that bar is returned.
Where destructuring in ES6 allows you to easily get properties out of an object, this shorthand property syntax allows you to easily push properties in. It's like destructuring backwards. So if I have a first name and a last name and I want to create a person, I can just say first name, last name, and then when I log out my person and I run this, you can see that it logs out an object with a first name of John and a last name of Lindquist. And if I wanted to build some more objects, like I want to build a team, so I have a mascot with a moose, and then I wanted to build a team like this where I have a person and a mascot, and then I log out my team. I have a team object with a person of first name, last name, John and Lindquist, and with a mascot of moose. So this syntax allows you to easily construct objects with the properties and things you already have and just build them up however you'd like. ES6 comes with some object enhancements. So if I want to create a car with that color and speed, I can just say color, speed, and then log out car.color and car.speed. So when I run this, you can see I get red and 10. That's because if you declare a property with the exact same name as something, it'll treat it just as if you did color, color, and speed, speed. So this is the ES5 way, and this is the ES6 way. This even works for functions, so if I create a function called go and say vroom, I can simply add another property here, call it go, and then say car go. Then I'll run this, and you can see it says vroom. Another cool thing, I'm going to format this just a little bit, put these on new lines, is that instead of using the function keyword, I can actually cut and paste this here. Then I'll just delete that. And now this is valid syntax for declaring a function on an object. So if I save and run again, you'll see I get the same result. So this is the ES6 way, and that's the ES5 way. So it's basically a shorthand that saves you some typing. Now the last fun trick to show you is that if you type something like this, you can actually have a computed property where it'll evaluate this. This is pretty much just like if you're to do car go like that, but now you're doing it inline inside of an object declaration, and this will still work when I run it. So I ran it and got vroom still. So I can actually extract this go. So we'll cut that out, say var drive, paste it in there, and then we can put drive in here, hit save, run it, and we still get vroom. So you could do any sort of string concatenation or evaluation in there to generate some sort of string which would evaluate into the name of something that you could then call later on. The spread operator allows you to take an array and spread it out into its individual items. So if I log out an array with 1, 2, 3, you can see I get an array, so you have the brackets with 1, 2, and 3. If I put the 3 dots in front to say I want to spread this array and I hit run again, you can see I get 1 and 2 and 3 with no brackets around it. This actually allows us to push elements easily into other arrays. Before, if I were to do first push second and log this out, you'll see I'll get 1, 2, 3, and then another array inside of my array. But instead, if I spread out the second array and push that in, you can see I get the individual items pushed in. And I could actually duplicate that, hit save, and you can see I get 1, 2, 3, 4, 5, 6, 4, 5, 6. So I'm pushing in the individual items over and over instead of pushing in arrays. Now this even works for doing things like pushing in an array of parameters. So if I want to add 3 things and then push in my first collection there, hit run, You can see I get 6, which is 1 plus 2 plus 3. So I just passed in first, and then I spread it out into 1, 2, and 3. And I could do the same thing for second and run this. And you'll see I'll get 6 and 15, 15 being 4 plus 5 plus 6, which is 4 plus 5 plus 6. Because again, these 3 dots are spreading the array out into its individual elements. If you have ever worked with strings in JavaScript, you've most likely concatenated 2 strings by just saying the variable, then plus, and then adding a string to it. And then when you run it, you just get hello world all put together. ES6 allows you to put the variables inside of your string, so I'm going to surround this with the grav, so I'll put one there, and I'll put one here, and then instead of doing plus and then quote, I'll just surround this guy with the $ curly brace and then close curly brace. And you'll see if I rerun this, I'll get hello world. It actually maintained the space here because I forgot to delete it, so if I delete that and run it again, now we'll get hello world without the space. And it actually respects white space even across multiple lines, so if I put some lines in here and I say hello and then tab world and run this, you'll see I get some blank lines, hello all the way at the left, and then a couple tabs and then world and then more blank lines. So I could pull off things like hello you crazy world, how are you, and rerun this, and you can see we can manipulate strings however we'd like. And if I want to extract any of these into variables, I could just, instead of world here, I could just do place, and then I can do place. We'll just say planet, and rerun this, and you can see we get hello you crazy planet all the way out here. It's also worth noting that you can do expressions inside of these braces. So if you want to do x plus y and just show y and just show x and then run this, you can see we get 1 plus 2 equals 3, and this is 1. There's the string plus, there's 2, there's the string equals, and then x plus y is the expression. Lastly is a basic introduction to tagging these string templates. I have it's, and then the hour of the day, and then I'm sleepy. So if I run this, you'll see that it's 15 or 3 o'clock and that I'm sleepy. But I don't get sleepy until after 20, so all I have here is this, and how am I going to make this into a variable? Well, I can actually parse out this message and get this value and change this string based on that value. So I'm going to create a function called tag. And notice I don't put any sort of parens or anything around this. I just type the function name. And then I'll say function tag. You can name it whatever you want, tag or parse or whatever. And then it takes these strings and the values. These strings being an array. So we'll log this out. The array of it's and I'm sleepy are the 2 strings. So this piece and this piece. And then the values are the values found in here. So when I log this out, this will be an array with just 15 in it. So we'll switch this over to a value. We'll just make it an empty value. And then we'll say if the first value, so value 0, is less than 20, I'll assign the second value and say this should be I'm awake. Then we'll return a new string. So 2 backticks, and then we'll just say strings 0, values 0, strings 1, and values 1. Then once we log this out, you can see it says it's 15, I'm awake, because 15 is less than 20, and we assign the second value, which is this guy, to awake. Now there's much more advanced stuff you could do with this, such as parsing HTML and using regex and everything, but we're going to end right there for right now. Typically in JavaScript, if you have an object with a property and a value and you want to log out this value, you would do some sort of assignment. So we'll just say object, and then when you log it out, you would say that object and then the property name. You could run it and you'd see the value in the log. Destructuring allows you to do this in a little bit different way, where instead of doing this sort of assignment, I would say, look up the color property and make that available so that I can just log out color. And when I run this again, I'll just get blue again, meaning that this says find this guy and assign it to, so I have blue here available, and now color is available for me wherever I want to use it. Now this also works if I have multiple properties and I want to get, say, the color and the position. I could just say color, then comma, position. And then I can log out the color and the position. And they're both available now, so I can log out blue and forward. A very common scenario where you will see destructuring come into play is when you have a function which returns an object, but you only want, say, the name and the state off of that return. So I'll just say var, and then I'll say name comma state, and then I can simply use the name and I can use the state, and I can run this and I can get John and New York because name was found here, which was John, and state was found here, which was New York. So once I log them out, I got only those things that I wanted. If you want these named something else, you can actually just put a colon in here. I'll say first name and I'll say location. This means still look up the name, but instead assign it to first name, look up the state, but instead assign it to location. So that when I go first name here, and I go location here, and I run this, I'll still get John and New York. Now where this gets crazy and also a little awesome is when you have an array and you only want the first item and the fifth item, and you don't care about the second, third, or fourth. I can do the array syntax, so var and then assign an array. I'll say first, and then second item don't care about, third don't care about, fourth don't care about, but I do want the fifth, and I'll just name it first and fifth. And I'll log out the first item, then I will log out the fifth item. Then when I run this, you can see I get red because first is assigned to red, and orange because fifth is assigned to orange. And if I wanted to start putting in second, third, fourth, I could, but right now they're not accessible because there's just empty commas in there. For this example, we have an array of people, which are just objects with some people, first name, last name, etc. on them. And I want you to watch very carefully as we do this, because I'm going to take the people, I'll go through them with a for each, and then we'll pass in a function. I'll use the arrow syntax. So that's the arrow syntax for a function. And I'm going to destructure the parameter that comes in. This would typically be the person. And I'll say I only want the first name off of it, so that when I log this out, I can get the first name, and I can run this, and I can log out all of the first names of those people, because what happened is this function took in the destructured version of this, saying only give me the first name of all of these people that come in, and then I can log out just the first name. And lastly, to combine a couple of these concepts, if I want to get Skylar, I can actually say, use that array syntax, and I'll just say comma Skylar, and assign that to people, meaning that this is going to skip the first one, look up the second one, and name it Skylar. Then I'll make a function which I'll call log email, which will take a destructured of that object of just the email property, and I'll say log email. And then when I say log the email of Skylar, and I run this, it logs out Skylar's email, which is right here, because it looks up the second item, names it Skylar. This is not looking up the name Skylar, it's just naming it Skylar from people. I'm logging Skylar's email, which is destructuring that Skylar object, and only taking the email off of it and logging out the email string, which is this.
ES6 or ES 2015 introduces a standardized module format. I have an indexed HTML file here, and I've loaded it here just with a browser sync server so that we can get some live reloading. If I go ahead and type this, we'll say with Webpack and Babel. See that reloads. We have an entry point already set up, and if I just log to the console. Now let's create a function here that's going to sum two numbers. It's going to take A and B, and we'll just return that, A plus B. And if we want to log that out, we'll just say this. 2 plus 3. And we'll take the result of this, 2 and 3. Let's extract this sum2 function out into an addition module. We'll look here in our source directory. We'll just create a new file, and we'll put this within a math directory, and we'll call this addition. See that we have the sum2, and we need a way of exposing this, and that's going to look like this. We can export, and we'll just give it the name of the function. It's going to expose this sum2 function when we import the module. And what that looks like, we can say import. We'll just import sum2 from, and if we look at our directory structure, we had the math addition. Expand that. Now let's add another function to the addition module, and we will add 3 numbers together, 2 plus 3 plus 4. And we'll just create this. We'll call this sum3. Now we're going to import that the same way. We'll add it to this list here, sum3. And now let's just define that. And now let's export that. Add it to our exports, sum3. And we can see over here that we are importing that successfully. Now there's a few variations of how we can accomplish both importing and our exporting. So let's take a look at maybe how we can export this a little differently. You can actually export directly on the function definition like this. We can just say export, export, and we'll drop this, and we're still reloading just the same. Now there's a few different ways that we can import these, and let's take a look at a few. I'll give this a little more breathing room. We can give each of our import statements an alias. We can import sum2 as add 2 numbers. If we run this, we'll see that sum2 is not defined. But if we update this to use our alias, add 2 numbers. Now let's import the module as a whole. We'll just copy this path here and we'll say import everything as addition from our path. And we'll drop this import statement, and we'll just need to make a few updates here. So this is going to be called sum2. And actually, since we're importing the module as a whole as addition, these are going to be on that addition object. And let's update these numbers just so we can see a little more change on that side. Now we've seen how we can define and import our own custom modules. Let's import a third-party package. And let's create a module here for some dummy user data. And we'll just call this data users. And I'll paste in this array of users that I have here, and we'll make sure that we export that. I'll head over here and we will import users from our data users module. And let's log that out and just make sure that everything looks okay. And we have our object over here of our users. If we drop each of those down. And let's pull Lodash in and make use of the where function that it provides us. npm install save Lodash. And while that's installing, we'll go ahead and we'll just import star. And we'll give it the alias of the underscore from Lodash. And we're going to be using the where method. So let's go ahead and use that where users. And what we're going to be looking for is we want to grab the age of 36. So we should just get Barney back, where the age is 36. If you look at our results here, we got 1 user back with the name of Barney. I've covered a few usages of importing and a few different styles of importing and using aliases, exporting, and we saw that we can export our functions directly. If you're looking for more information, I'd head over to MDN documentation, or Babel has some pretty good summaries of the ES6 module syntax.
Here we have a list of prices that belong to products inside of a store. And we'd like to highlight the prices that are less than $10. and we don't have access to the server code to be able to do that on the server. So we're going to do it with JavaScript on the client. So let's grab our products and store them in a variable called products. And we'll do that by saying document.querySelectorAll. And we know that each of these has a class name of product. So we'll use that to grab them. And then let's log these out to see what they contain. So we can see that we have our products. And if we open this up, we can see that they are of the type node list. And the problem with the node list is that it's like an array, but it's not an array. So it doesn't have all of the typical array methods that we'd want to use, like filter and for each and reduce. So what we can do is we can convert this node list into an array, and then we'll be able to use the array methods on the list. So in the past, there have been a lot of hacky ways to do this, but now with Ecmascript 2015, we have a native way to do it with the array.from method. So I'm going to go up here and wrap my node list call with array.from. If we log this out, we'll be able to see, if we open this up again, that it's now of type array. So now we can use the array methods to solve our original problem of highlighting numbers that are less than 10 in the list. So what I'm going to do now is say products, and we'll filter those products, and we'll filter if the product, the number inside of that product, so parse float, and we'll grab the product's inner HTML, and we'll check if it is less than $10. And then when we get that list of the products that are less than $10, we're going to for each over them. And for each of those products, we're going to say product.style.color, and we'll set that equal to red. And now we're highlighting the items that are less than $10. So you can see that being able to convert a node list or any other type of iterable collection into an array can be very useful.
In today's lesson, I want to go over promises with ES6 or Ecmascript 2015. Promises in ES6 are very similar to those of Angular's $Q service if you're familiar with that framework. First thing I want to do before we start explaining what promises is and how to use them is just build out a basic skeleton that we can add to throughout the video. To get started, we'll go ahead and create a new variable, which we'll just call D, and we'll set that equal to a new promise. The callback inside of a promise takes two arguments, resolve and reject. You'll notice that we're using the ES6 arrow function syntax throughout this project. Promises can either be resolved or rejected. When you resolve a promise, the .then will fire, and when you reject a promise, the .catch will fire instead. Usually, inside of your promise, you have some sort of logic that decides whether you're going to reject or resolve the promise. So let's go ahead and build a basic if-else statement here. Inside the if statement, we'll go ahead and resolve the promise. We'll pass in a string of hello world. And inside the else statement, let's reject the promise, and we'll just pass in a string of no bueno. Now, because we're just evaluating the Boolean true inside this if statement, we know that our resolve is going to fire. To get an idea of what this looks like, let's go down to our d.then. The then method callback also takes an argument. This one we'll call data. The value for data is the argument that is passed into the resolve method. So in here, let's just go ahead and console log, and we'll say success, and we'll print out our data. Alternatively, in the catch method, we also have a callback function as the argument, but here what will be passed back is the information that's supplied into the reject method of our promise. So why don't we just go ahead and console.error, and here we'll say error, and we'll spit out that error data that's supplied back to us. If we come back into our console and we run this logic, we'll notice that success hello world is returned to us because that's what we have specified in the callback of our then method. If we go up to our promise and we change this true to false, we'll cause our reject to fire off, and no bueno will be passed through instead. So let's come back to our console and run it again, and we notice we get our error, no bueno. Promises are useful for a lot of things. Most importantly, they allow you to perform asynchronous operations in a synchronous-like manner. To get an idea of what this asynchronous behavior would look like, let's go ahead and create a timeout, and inside of the timeout, we'll create a function. And in this function, we'll just put our if-else statement that we were using previously. Let's set a timeout here of 2 seconds. And we still have our false being evaluated by the if statement. So after a 2-second delay, we should see that our error no bueno is passed into our console. Let's come back down here and run it again. And we have a 2-second delay where error no bueno is returned to us. We can go ahead and change this to true, run it again, and this time we'll see that we get success hello world after our 2-second delay. There's several different methods you can use when dealing with your .then and .catch callbacks. If you don't prefer to use the .catch method, you could then instead supply a second argument into the .then method, which will act as an error callback. So in here, let's go ahead and pass in our error again as our parameter, and we'll just console.error, and this time we'll do a new message so that we can see that it's actually our second callback of the .then method which is being called. Let's go back up to our if statement, change true to false so we can make sure that our reject is what's fired. We'll come back down into our console, we'll run the code, and again after our 2-second delay, we'll see that the new error message no bueno is returned to us. I prefer to use the .catch method for rejects and .then for resolve only. This ensures that I can always be certain that if I have a function inside of the then method, that it is my success callback and I can put in the appropriate code. .then and .catch can also be chained together. So let's go ahead and chain these two things together, run our code again, and we'll notice that we still get our error message. Alternatively, we can decide to chain several .thens together and have them called in succession. We'll notice now if we change our if statement to true and run our code, the resolve will be called and both .thens will fire one after another. Let's come down and run our code. And we see that we get success and success2. Notice that success2 is undefined. This is because the data that's available in the callback of the second then is not what is originally passed into the resolve, but rather what is returned from the original then method. To see a working example of this, let's go ahead and return a value from our first .then, which will then be passed into the second .then. If we come back to our console and run the code again, we'll notice that rather than undefined, this time we get foobar passed back to us. One more important thing to note is that whenever an error or exception is thrown within the promise, it will automatically trigger the .catch to call regardless of when that error is thrown. To see a basic example of this, let's go ahead and throw a new error. Run our code again, and we'll notice that this time our error is returned to us, even though we're evaluating true, which means our resolve should fire. This statement remains true regardless of when the error is thrown throughout the promise. For example, if we come into our second then statement, we can go ahead and throw that error in the second .then, and we'll notice that the catch will also fire. Now, if we were to add that error to the first .then that second then would never fire because it's going to go straight to the catch. And those are some basic examples of how to use promises with ES6 or Ecmascript 2015.
You make a generator by adding an asterisk right here after the function keyword. I'll go ahead and add a log statement saying that you called next. And you might think that if I call greet, that it would log out you called next, but nothing happens. So if we assign something like a greeter to this greet, and then we see what the greeter is, you can see that the greeter is actually an object. So it did not invoke this, it actually created an object which I can call next on. So when I call greeter.next, and I'll just call this next and log that out, you can see that next is undefined and done true. You can also see that it finally invoked our log statement saying that you called next. Now this is undefined because we didn't yield anything from our generator, and it's done because it's gone through all of the yield statements, which are actually none right now. So if I yield a simple hello and run this again, you can see now I get value hello and done false. So it logged out our statement, it returned hello, and it's not done yet. It will actually be done on the next pass through next. So if I call next again, and I'll just name this one done, and I call the log statement again, so I'll just log out done. You can see that I get hello on the first pass with done is false and undefined with done is true because there are no more yield statements after this one, meaning it has iterated and gone through all of the yield statements. So if you have multiple yield statements like how, are, and you run this with only calling next once, you can see that it stops after calling how. So this is not called, that's not called, and that's not called. If you were to create any objects or anything inside of here, they would not be created until you called next, meaning that you can put stuff in here that's not created until you explicitly need it. So if we go ahead and call next 3 more times and run it again, you can see it logs out each log statement, then the yield, the log, then the yield. So it logs this, then yields that, then logs this, then yields the next one. Now, because it's an iterator, you can also use the for of syntax. So we can say for word of greeter, and then log out the word, and then run that. And you can see the output is basically the same. So how are you? The main difference is that this is grabbing the value off of the next. So to do that by calling next, we'd have to revert this and say dot value, then run it again, and we get the same output. It's really easy to get mixed up when you start assigning things to yield statements. So if I say let friendly equal yield how, and then I try and log out friendly, you might expect it to log out how because that's what it's yielding. But if I run this, you'll see it's actually logging out undefined. The way that this works is that the next step through the iteration, so if I say the heck, we'll basically send this back through and assign it to this friendly. So if I log this out now, you'll see I get how and then the heck. So that means you can start building things through the iteration process. So if I yield friendly plus R, and then I assign friendly to this, and then I yield friendly plus U, and I pass in silly ol, and I run this again, you can get how the heck are silly ol you, because this message is being returned here when the next step is run and assigned to this friendly, and I yield that part of the friendly, and then this comes from here, which is being assigned here, and then it yields that final statement. One thing to note is that because this assignment happens on the run after the first one, it's actually impossible to pass a value in here. So if I try and say first and run this, I'll get an error saying sent value to a newborn generator, because you haven't given this a chance to run and iterate and go to the next step where you could actually pass in a value. Lastly, generators also help you work with infinite sequences. So if I wrap my yield with a while true, which is never going to stop looping, I can safely yield this x and y point, knowing confidently that this stuff isn't going to evaluate until the next step through after the yield process. So it will safely pause instead of infinitely going through this while loop. So when I run this, you can see I get 0, 2, 4, 6, 8, and so on, 0, 1, 2, 3, 4, and so on. And I could generate these forever, and they're also only created when I request them through the yield. They're not created ahead of time. And don't worry, we will dive more into practical use cases of generators in future videos.
Today we're going to do an introductory overview of maps and weakmaps with Ecmascript 2015 or ES6. The map object is just a simple key value map. JavaScript objects and maps are very similar to each other, and before the introduction of maps in ES6, objects were used in order to keep track of different key value pairs. However, maps does offer us a few bonuses that we don't get from objects. For example, an object has a prototype, so by default there are keys in the map, whether the user has added them or not. Secondly, an object key has to be a string, whereas in a map it can be anything from a function to an object to all other types of primitives. Lastly, maps have methods on them that allow you to easily get the size of and keep track of the size of your map, whereas to objects, there's no innate method that allows you to quickly get those answers. So the first thing that we want to do is inside of our JS bin is just go ahead and make a map. So we'll just do var mymap equals new map. Next, let's list out the API that we'll be going over in this tutorial. We have the set method and then the get method, followed by the size property, as well as the clear and has method. First thing we want to do is go ahead and set some key value pairs on our new map. To do that, we'll take advantage of the set method, so we'll just do mymap.set with a key of foo and a value of bar, followed by mymap.set with a key of hello, followed by a value of world. To get an idea of what the get method does, let's go ahead and just console log out mymap.getFoo. If we come over to our console and we run this, we'll notice that bar is returned. That's because that is the value associated with the foo key inside of our map. If we attempt to access a value that does not exist, we'll get undefined back. Next, let's go ahead and look at the size property that we have available to us. If we console log out mymap.size and go ahead and run the console again, we'll see that 2 is returned to us because we have 2 items inside of our map. The clear method is quite self-explanatory. If we go ahead and insert a mymap.clear above the console log, we'll see that when we run the output, we get 0 back because there's no longer any items in our map. Next, let's look at the has method available to us through the map API. If we go ahead and write has with an argument of foo, we'll see that true is returned back. If we insert a key that does not exist, such as QWERTY, and go ahead and run that, we'll see that false is returned back. Map gives us several iterators that we can use to go over our map to access the keys, values, and entries. Those are the keys method, the entries method, and the values method. To get an idea of what that looks like, let's go ahead and create a for of loop in here. And we'll do var key of mymap.keys, and we'll console log out each key. If we clear out the console and run it again, we'll see that we get foo and hello returned to us because those are the 2 keys inside of our map. Alternatively, we can go ahead and do a for of loop for the values inside of our map. Let's go ahead and switch the variable so it makes a little bit more sense, and we'll console log that out, and we'll see that bar and world is returned to us, as those are the values that are stored within our map. Lastly, we can iterate over the entries. What the entries does is it returns to us an array made of arrays where the first item in the array is the key and the second item is the value. So if we do var key and value of mymap.entries and console log that out, we'll see that we get foo equals bar and hello equals world. Next, I wanted to quickly go over weakmaps in ES6. What a weakmap means is that no references are held to the keys of the map. With no references being held to the keys of the map, it allows it to be available for automatic garbage collection that's available to us in JavaScript. Because no references are kept to the keys, that means that they are enumerable, or we cannot iterate over them. Because of this, the options of what is available for us to use as keys in our map is limited when using weakmaps. For example, with a map, we can use anything as its key. To show that, let's create var myObject, set it equal to an empty object, var myFunction, set it equal to an anonymous function, and now in our set methods, we can swap out foo and hello from myObject and myFunction, and we can run our output and see that the entries method shows us that we have our object and our function is the keys for bar and world. The important thing to note is that we can also use strings for our keys. We can say set string with the value of 2. We can run our output again, and we'll see that string 2 is given back to us as a key value store. Now if we go up here and we change var mymap to a weakmap and we run this again, we'll see that we get some errors. The first thing we get is that we cannot use a string as a key in our weakmap. If we go ahead and get rid of that string and run the output again, we'll see that we get a new error. This time we see that entries is not a function. Because of the enumerable nature of our weakmaps, that means that all of these iterator API methods available to us on the map is no longer available on the weakmap.
So what we have here is an AJAX function using ES6 parameter object destructuring, and we're providing default values. As you can see, when we call our AJAX function, we're getting not only the values we passed into the function, but we're also getting default values for the things we didn't pass, like type, data, and isAsync. We could at this point remove the URL and success properties when calling the AJAX function, and you'll see we're providing default values for them. But that doesn't seem quite right. Those properties should probably be required. So let's do that. So what we're going to do is come up here and create a new function called required parameter and give it a name parameter. And then we're going to throw a new error. And it will say missing parameter. And we'll say quote name end quote. Instead of setting a default value for the URL property, we're going to call our required parameter function instead. So what will happen is if our AJAX function is called without a URL property, the required parameter function will be invoked instead, resulting in an error exception saying missing parameter URL. Likewise, we can do the same thing for the success property. Now, if we try to call the ajax function with only the URL property, we should see a missing parameter exception for the success property. And if we provide a value for the success property, then we should see all of our parameters logged to the console. So by leveraging the default value feature of object destructuring to our advantage, we can provide required parameters as you've seen demonstrated.
In this video, we're going to talk about ES6 REST parameters versus the arguments keyword in ES5. What the arguments keyword does is return back to us an array-like object of all the arguments that were passed into our function. To see a simple example of this, let's go ahead and create myfunc and just console log out the arguments keyword of that function. Down below, we'll call myfunc with arguments 1, 2, 3 and run that to see what the console output is. As you can see, we're returned back an array-like object with all of the arguments that were passed into the function. Because it is array-like, there are certain properties that are available to us on the arguments keyword that are also available to us on an array. For example, in our console log, let's go ahead and add the dot length and run the function again, and we'll see that 3, the length of our array-like arguments, is returned back to us. It's important to note that most methods available to us on arrays are not available to us on the arguments keyword. For example, let's do a for each on the arguments. In our callback function, we have our value, index, and array parameters, and let's just console log out the value for each loop. If we run this again, we'll see that arguments.forEach is not a function. That's because while arguments is array-like, it does not have all of the methods that the array prototype has on it. To show an example of how we worked around this in ES5 and how REST parameters mean that we don't have to anymore, let's create a new constructor. We'll call this constructor store, and in it we'll return an object with some methods. The first one will be the add method, and what this will do is add new items to something inside of our store. Let's create var aisle, and we'll have some categories like fruit and vegetables, which have arrays of all the fruits and vegetables in that aisle. Let's return that back to us as well so we can access it from outside the constructor. And inside of our add method, we'll have a function that takes this specific aisle as the first parameter, and then all the items we're adding to that aisle is the remaining parameters. In the past, with ES5, the way that we turned our array-like arguments into an actual array was to use the splice call hack. The way we did this was we called splice on an array, and then we called it with our arguments starting at the first index. What this does is exclude the category argument, but takes the remaining arguments and puts them into an array that we've called items. If we console log out items in this function, we can see the array that's created. Let's create a new instance of this constructor, and we'll call it myGroceryStore. Down below, we'll call myGroceryStore.add, and we'll be adding to the fruit aisle apples and oranges. If we clear out our console and run this again, we'll see that apples and oranges are now the fruits inside the items array. Now that we have an array, we can call for each on it, and with our value, index, and array arguments, we're going to go ahead and push all of these new fruits to the fruits category. After calling add on our new grocery store, we can access the aisle and see that the fruit aisle has apples and oranges added to it. Now let's simplify this with the new REST parameters of ES6. The way that we access these is by doing 3 dots followed by the variable we want to represent the array of the remaining arguments. Because this is already an array, we don't have to transform our array-like arguments into an actual array. So we can just console log out items, run this again, and see that we get an array of apples and oranges immediately. We can also see that our fruit aisle has the apples and oranges items inside of the array. All arguments declared before the REST parameters will be represented by those variables. However, any remaining arguments will be inserted into the new REST array. Because of this, we don't have to remove category from our array as it is already not included.